Good afternoon to all. My name is Dheeraj Kumar, lecturer, Department of Mechanical Engineering at IIMT College of Polytechnic, Greater Noida. Today, online session on a gas turbine. So, gas turbine. A gas turbine is a machine delivering mechanical power or thrust. It does this using a gaseous as a working fluid. The mechanical power generated can be used by, for example, various industries such as power generation, oil and gas industry, and marine industry. The outgoing gaseous fluid can be used to generate a thrust. In the gas turbine, there is a continuous flow of the working fluid. The efficiency of the gas turbine is 20 to 30%. The major application of a gas turbine is power generation field, oil and gas industry field, and marine propulsion and aircraft. This is the working of the gas turbine. Gas turbine consists of compressor, combustion chamber, and exhaust. Compressor compress the ambient air so the pressure and the temperature of the air is increases. The high pressure and high temperature air is supplied to the combustion chamber. In the combustion chamber, air and hot gases are mixed and they are burned. After the burning of the fuel, the hot gases is generated. These hot gases is expanded in a multi-stage turbine. The multi-stage turbine have fixed blade as well as moving blade. This is the sectional view of the gas turbine. There is a three main part of the gas turbine. This is the compressor of the gas turbine and this is the turbine. This is the multi-stage turbine in which fixed blade as well as moving blade. In between compressor and turbine, there is a combustion chamber. Compressor and turbine is coupled on a single shaft. Air compressor. The air compressor and turbine are mounted at either end on a common shaft with the combustion chamber between them. Gas turbines are not self-starting. A starting motor are used to start the gas turbine. The air compressor sucks in air and compresses it, thereby increasing its pressure. Combustion. Second part of the turbine is combustion chamber. In the combustion chamber, the compressed air combined with the fuel and resulting the mixture is burned. The greater the pressure of the air, so that the better fuel mixes inside the air and burning is better. Modern gas turbines usually use liquid fuel, but they may also use gaseous fuel, natural gas, or gas produced artificially by gasification of a solid fuel. Turbine. Hot gases move through multi-stage gas turbine. Turbine. Hot gases move through multi-stage gas turbine like steam turbine. The gas turbine also has stationary as well as moving blade. The stationary blade guide the moving gases to the rotor blade and adjust the velocity of the gases. Shaft of the turbine is coupled to a generator. So, generator is produce electricity. Gas turbine is working on a Breton cycle. In a Breton cycle, there is a four thermodynamic process. First, process 1 to 2 is called reversible adiabatic compression process or isentropic process. Process 2 to 3 is constant pressure heat addition process, and process 3 to 4 is a reversible adiabatic expansion process or isentropic expansion process, and process 4 to 1 constant pressure heat rejection process. This is the four thermodynamic process which is used in a Breton cycle or gas turbine. This is the PV diagram of the Breton cycle, and this is the TS diagram of the Breton cycle. So first we talk about the thermal efficiency of Breton cycle. For unit mass, the heat supplied during process 3 to 1, there is the heat supplied. Heat supplied is Cp T3 minus T2, and there is the heat rejection Cp T4 minus T1. So heat supplied during process 2 to 3 Cp T3 minus T2, and heat rejection process 4 to 1 is Cp T4 minus T1. So net work done is Q supplied minus Q reject. So W is equal to Cp T3 minus T2 minus Cp T4 minus T1. Thermal efficiency of Breton cycle is defined as net work upon heat supplied. This is our net work and this is the heat supplied. So work done is equal to net work Cp T3 minus T2 minus Cp T4 minus T1 upon Cp T3 minus T2. Separately divided Cp T3 minus T2. So efficiency is equal to thermal efficiency is equal to 1 minus T4 minus T1 upon T3 minus T2. This is the equation number 1. So calculate pressure ratio. This is the pressure ratio. P2 upon P1 is equal to P3 upon P4. This is the low pressure and this is the high pressure. So P2 upon P1 is equal to P3 upon P4. P2 upon process 1 से 2 is a reversible adiabatic compression process. So T2 upon T1 is equal to P2 upon P1 की power gamma minus 1 upon gamma. So P2 upon P1 is written as a RP. RP is the pressure ratio. So T2 upon T1 is equal to RP की power gamma minus 1 upon gamma. This is written in this condition. T2 upon T1 is equal to P2 upon P1 की power gamma minus 1 upon gamma is equal to RP की power gamma minus 1 upon gamma. So T2 is equal to T1 RP gamma minus 1 upon RP की power gamma minus 1 upon gamma. For isentropic expansion process in 3 से 4, the process is called isentropic expansion process. In isentropic expansion process, T3 upon T4 is equal to P3 upon P4 की power gamma minus 1 upon gamma, that is RP की power gamma minus 1 upon gamma. T3 is equal to T4 RP की power gamma minus 1 upon gamma. So equation 1 is 1 minus T4 minus T1 upon T3 minus T2. First of all, T1 and T2 are common. Take both sides. T4 upon T1 minus 1 upon T3 upon T2. This value is RP की power gamma minus 1 upon gamma, and this value is RP की power gamma minus 1 upon gamma. This is cancel out. So 1 minus T1 upon T2. T1 upon T2 is equal to P1 upon P2 gamma minus 1 upon gamma. So efficiency of Breton cycle is 1 minus 1 upon RP की power gamma minus 1 upon gamma. 1 minus 1 upon RP की power gamma minus 1 upon gamma. There will be two type of a gas turbine: open cycle gas turbine and closed cycle gas turbine. In an open cycle gas turbine are shown in a figure. In an open cycle gas turbine consists three major parts, major component. पहला compressor, दूसरा combustion chamber and turbine. Process 1 to 2 is reversible adiabatic compression process. So there air is compressed by the compressor, so the pressure and the temperature of the air is increases. High pressure and high temperature air supply to the combustion chamber, and where fuel is sprayed, so fuel is burned inside the combustion chamber. Process 2 to 3, constant pressure heat addition process. So after the burning of the fuel, hot gases is generated. These hot gases is supplied to the turbine, and these hot gases expand inside the turbine. The expansion process is called reversible adiabatic process. Process 324 is reversible adiabatic expansion or isentropic expansion process. During the expansion, mechanical power is developed and pressure and temperature both are reduced, and low pressure and low temperature hot gas is supplied to the ambient. In an open cycle gas turbine, fresh air mixture is supplied to inside the cycle. Each and every cycle, fresh air is supplied in each cycle. Open cycle gas turbine. It consists of a compressor, combustion chamber, and a turbine. The compressor takes in a ambient air and rises its pressure. Heat is added to the air in combustion chamber. By running, the fuel rises its temperature. The heat gas is coming out of combustion chamber and then passes to a turbine where it expands and produces a mechanical work. The efficiency of the compressor. So compressor efficiency is defined as isentropic work upon actual work. If you talk about TS diagram, this is the process is isentropic expansion. Once the two reversible adiabatic or isentropic expansion 2 to 3, constant pressure heat addition process 3 to 4 is a reversible adiabatic expansion process, and 4 to 1 constant pressure heat rejection process inside the turbine, inside the atmosphere. So if compressor efficiency is defined as isentropic efficiency upon actual efficiency. Isentropic efficiency H2 minus H1 upon H2 dash minus H1. This is the process 1 to 2 is ideal process, and 1 to 2 dash is the actual process. So isentropic compression process H2 minus H1, enthalpy is the function of temperature. So Cp T2 minus T1 or upon H2 dash minus H1, enthalpy is the function of temperature. So written as H2 dash minus H1, written as Cp T2 dash minus T1. Cp is cancel out T2 minus T1 upon T2 dash minus T1. If you talk about efficiency of a turbine, actual turbine work upon isentropic turbine work. This is the expansion process. Actual turbine work is H3 minus H4 dash upon isentropic turbine work is H3 minus H4. So actual turbine work H3 minus H4 upon H3 minus H4 dash upon H3 minus H4. Enthalpy is the function of temperature. So this is written as Cp T3 minus T4 dash upon Cp T3 minus T4. Cp is cancel out T3 minus T4 dash upon T3 minus T4. Actual compression work is equal to Wc Cp T2 dash minus T1. And actual turbine work is written Wt is equal to Cp is written as Wt is equal to Cp T3 minus T4 dash. Actual net work, compression work minus turbine work is called actual net work. Wc minus Wt Cp T3 minus T4 dash minus T2 minus T1. Thermal efficiency is defined as net work of the cycle to the heat supplied. Cp T3 minus T4 dash minus T2 minus T1 upon Cp T3 minus T2 dash. Cp is cancel out T3 minus T2 dash. T3, this is term kept in one side. T3 minus T2 dash minus T4 minus T1 upon T3 minus T2 dash. Efficiency is equal to 1 minus T4 dash सेपरेटली डिवाइडेड किया 1 माइनस टी फोर डैश माइनस टी वन अपॉन टी थ्री माइनस टी टू डैश दिस इज सेपरेटली डिवाइडेड टी थ्री माइनस टी टू डैश इज सेपरेटली डिवाइडेड so 1 minus T4 dash minus T1 upon T3 minus T2 dash. Turbine work ratio is defined as is equal to turbine work to the compression. Turbine work ratio is defined as turbine work to the compression work. This is the another type of the gas turbine, closed cycle gas turbine. In the closed cycle gas turbine, air is recirculated again and again. There is four major components are used in a closed cycle gas turbine. First is the compression, second is heat exchanger and turbine, and another heat exchanger. Compressor process 1 to 2 is called reversible adiabatic compression or isentropic compression process. During the compressor, air is compressed and pressure and temperature are increasing. These high pressure and high temperature air is supplied to the heat exchanger where heat is supplied inside the exchanger, inside the heat exchanger. So heat is exchanged from high temperature body. So the temperature of the compressed air is rises very high and high heat is generated. So high heat compressed high heat air is supplied to the turbine. This air is expanded inside the turbine and produce a mechanical work. The process 3 to 4 is called reversible adiabatic or isentropic process, and 4 to 1 is heat exchanger process. This process is kept at a constant pressure heat rejection process, and process 2 to 3 is called constant pressure heat addition process, and process 4 to 1 is called constant pressure heat rejection process. It is closed cycle gas turbine. It is uses air as a working medium. In closed cycle gas turbine plant, the working fluid, air or any other suitable gas coming out from the compressor is heated in a heater by external source at a constant pressure process. The high temperature and high pressure air coming out from the external heater is passes through the gas turbine. The fluid coming out from the turbine is cooled to its original temperature in the cooler using external cooling source before passing to the compression. The working fluid continuously used in the system without its changing of phase, and the required heat is given to the working fluid in the heat exchanger. Method of improving thermal efficiency of open cycle gas turbine. There is a three method to improve the thermal efficiency of the gas turbine, because efficiency is the gas turbine is less 20 to 30%. So improve the thermal efficiency by using first method intercooling, second reheating and regeneration process. First discuss about intercooling. Intercooling occur during the intercooling. There is a compression process occur in two stages. First, air is compressor, low pressure compression process, and the pressure and the temperatures and the pressure and the temperature are increases of some amount. The temperature is not desired because I want to increase only on pressure. So temperature is controlled by the providing the intercooler. These intercooler reduce the temperature after the low pressure compressor air, and these low pressure compressor air supply to the high pressure compressor, and this is again compress the air, so the pressure and the temperature again is increasing. Once a two-stage is the process is called low pressure compression process. This is the First, reversible adiabatic compression process. This is also high pressure compression process. Is reversible adiabatic compression process. This is intercooler is provided between low pressure and high pressure compressor. So this process is constant pressure heat rejection process 2 to 3. Then high pressure compressor compress the air and pressure and temperature are also increased, and this air supplied to the combustion chamber where fuel is supplied, and air and fuel mixture is burned inside the combustion chamber. So hot gases is generated. These hot gases is supplied to the turbine, and turbine these hot gases is supplied to the turbine. Hot gases expand inside the turbine and mechanical work is developed. The expansion process is also 5 to 6 process is the expansion process. This process is reversible adiabatic expansion process or isentropic expansion process. Expansion occur inside the turbine. This is the symptom. This is the working of intercooling. This is the process is 1 to 2 process, low pressure compression process where pressure is increased. This is the P1 pressure, this is the P2 pressure, and this is the higher pressure. So first compression, low pressure compression process 1 to 2. Then intercooling, this is the constant pressure line 2 to 3 is constant pressure line and heat is rejected. The temperature is decreases to T2 to T3, and after the third point, the compressed air supplied to the after the intercooler compressed air supplied to the high pressure compressor. So again pressure is increased T2 to T4 and temperature is increased. Pressure is increased P3 to P4 and temperature is increased T3 to T4. And again process 4 to 5 is called constant pressure heat addition process. In this, the fuel is burned inside the combustion chamber. 5 to 6 is called reversible adiabatic expansion process. This process occurs on a turbine. So during the expansion, pressure as well as a temperature are decreases, and process 6 to 1 constant pressure heat rejection process, and this is process occur in atmosphere T6 to 1. This is occur in atmosphere. Work input with intercooling. Work input with intercooling. Work input means compressor work. So first work is low pressure compressor work. This is low pressure compressor work H2 minus H1. Okay. So first we talk about actual compressor work. Actual compressor work. So actual process is 2 dash to 1 and 1 to 2 is ideal process. So H2 dash minus H1, enthalpy is the function of temperature. So H2 dash minus H1 is written as Cp T2 dash minus T1 plus high pressure compression process, work input through high pressure compression process. So C4 T4 dash minus T3. This is the equation. Work input without intercooling. This is the cycle 1L56. This is 1L561. This is cycle which have no intercooling. So without intercooling, the work done is equal to compression work. Compression work is work Cp TL dash. This is the point TL dash. Actual process is considered TL dash minus T1. So Cp, this TL dash is written as Cp TL dash minus T2 dash plus Cp TL dash Cp T2 dash minus T1. This is break in two parts. Cp TL dash minus T2 dash plus Cp T2 dash minus T1. By comparing the both equation 1 and 2, it can be observed that the work input with intercooling is less than the work input without intercooling. So intercooling is used to improve the efficiency of the gas turbine because input work is reduced, means compressor work is reduces. CP T4 dash minus T3. CP T4 dash minus T3 is less than CP TL dash minus T3. This is the reason the compressor work is less in when the intercooling is provided. So when the compressor work is less, the efficiency of the gas turbine is increasing. Again, method to improve the efficiency of the gas turbine by providing the reheating. Reheating in the output of the gas turbine has improved the expanding the gases in two stages with reheater between the two turbines. In the reheating, the expansion process are take place on two turbines. First high pressure turbine and another low pressure turbine. First gas is expanded in high pressure test turbine. These gases are again combustion inside the reheater and expand low pressure test turbine and work is produced. So this is the diagram of reheating process. 1 से 2 is the compression process, which is reversible adiabatic compression process, and process 2 to 3 is first combustion chamber is 2 to 3 is first combustion chamber where fuel is burned inside the combustion chamber and hot gases is generated. Hot gases is generated. These hot gases is expand in a high pressure turbine and produce a mechanical power. High pressure turbine and compressor are coupled with a single shaft, and high pressure turbine produce mechanical work which run the compressor of the cycle, and high pressure turbine after the low energy gases is passes through the turbine. This is also supplied to the another combustion chamber. This is called reheater, and again heat is supplied and the gases temperature is increases, and high pressure and high temperature gases is supplied to the low pressure turbine and work it produce. After this, hot gases is escape to the ambient or exhaust. This is the reheating process. During the reheating process, the efficiency work output is increases. During intercooling, work input is decreases. When the providing the intercooling, work input is increases, and when we providing the reheating process, the work output is increases. This is the diagram of reheating cycle. This is the process 1 to 2 is dotted process is each cycle. In each cycle, dotted process is called actual process, and not dotted line is ideal process. 1 to 2 is the process is the compression process, and 2 to 3 combustion chamber process. First combustion chamber at constant pressure process. Then expansion take place in high pressure turbine. This 3 to 4 process is high pressure turbine expansion process, and 4 to 5 process is again heat addition in a combustion chamber N2, and 5 to 6 is the process is again expansion in a low pressure turbine. So the work output is increased, and the dotted line is indicated as actual process of the cycle. So work output in reheating is CP. This work output, high pressure turbine work output plus low pressure turbine work output. So CP T3 minus, we talk about actual work output. So CP T3 minus T4 dash plus Cp T5 minus T6 dash. Work output without reheating is Cp Cp T3 minus TL dash. This is the process is without this cycle अगर extend कर दिया जाए तो this is the actual cycle and this is the actual isentropic work where no reheating takes place. So Cp T3 minus TL dash. This is process is Cp T3 minus TL dash. Cp, this is the combination of this and this. Cp T3 minus T4 dash plus Cp T4 dash minus Tn dash. When we compare about equation A and equation B, we found that the reheating is more work done as compared to without reheating. Since the pressure lines diverge to the right on the TS diagram, it can be seen that the temperature difference T5 minus T6 dash is always greater than T4 dash minus TL dash. So the reheating increase the net work. Intercooling, it decrease the compression work, and reheating increase the net work or work output. Regeneration process. So thank you. Regeneration process is again discussed. So thank you, sir. Thank you, everyone.